All right, everyone, we're going to get started. So please find yourself a comfortable seat. And I want to say welcome. My name's Charlotte. I'm a product manager at Qualia, and we're very excited to be hosting Meteor Night tonight. So I want to say a quick thank you to Heavybit and Malia from Heavybit for helping us set up here, and also Joe from Qualia for doing such a good job with all the catering. We're very excited about the speakers tonight. We're live streaming as well, so welcome to everyone far away. And our first speaker is Lucas Hansen. He's the CTO of Qualia, and he'll be giving a talk on 10,000 hours of Meteor. He has a lot of experience, and he's up first.
Hello, everyone. Welcome to Meteor Night. I am really excited that Qualia is able to start putting on this event. I have very fond memories of Meteor Night back when they used to do it regularly. When we were first starting off in Meteor as a company, I used to go to every single event, and it was amazing to talk to everyone and learn what people were working on, and it was just pretty awesome. So I'm super excited to get started on this again. Okay, so my talk is called 10,000 Hours into Meteor. My previous talk that I gave about 2 years ago is 3,000 hours into Meteor. And 10,000 is bigger than 3,000. Therefore, this talk is going to be better. But the main reason why I actually named it 10,000 Hours into Meteor was because I had to name the talk long before I decided what I was going to talk about. And this title is sufficiently ambiguous that it could actually be about anything. There are a lot of things that I wanted to talk about, but I decided to sort of show you guys the tools that Qualia has been building and what I think is possible with Meteor. So first, just a little bit about Qualia. Qualia was founded in early 2015. We are about 100 people, split between Austin and San Francisco. And we recently raised our Series B a few months ago, and we're growing really fast. What we do is we build software for the closing process. So the closing process is sort of what happens during the latter end of the real estate transaction. Lots of different moving pieces, but long story short, it's been pretty scattered across many different pieces of software, email. It's been pretty drawn out and frustrating. So what we do is we build software to bring that all on the same platform. Cool, so let's get started. All right, so Qualia loves Meteor. We are hosting Meteor Night, so that's sort of some evidence that we like Meteor. We've been using it since the very beginning, day one, and it's been just a fantastic experience. The amount of software that we have to build is just huge. The problem that we're solving is very, very complicated. And I actually don't think that we would be where we are today unless we had a tool like Meteor to help us build all these things. And I hope to convince you that Meteor is kind of a unique platform for this sort of rapid development. So I was trying to decide which kind of talks to give. And I could have had like a really long PowerPoint and talked about lots of random things. But instead I decided to just show a lot of demos, because I think demos are way cooler, and I'd like to get started with that. So I'm going to show 3 different internal tools that we've built, and I've built this around a demo that all of you guys can download and use either now or afterwards. Literally everything I'm going to show you is going to be in here. And so this is centered around 3 different open source tools. So the first open source tool is something called Reval. Reval is a live coding environment. I watch a lot of Brett Victor videos, and during a hackathon, I really, really wanted to build something like that we could use at Qualia. So I'm actually going to do a demo showing you how it works. But very briefly, what's going on here is you can click anywhere in this application, and it finds the code underneath your mouse and opens up, it sort of shrinks the screen in the top right, it shrinks it, and you can live edit the code of your application. And as you type, it will actually update the application without a server reload. And there's an alternate view, which is inspired by JS Fiddle, which lets you isolate a particular component and see all of the code that creates that component in the same place. So Reval stands for reevaluation. Especially in big Meteor applications, there's a couple issues. So one, as your Meteor application gets bigger, the rebuilds get slower, which is natural but often frustrating. And as your application gets bigger, the mapping between your source code and the actual application itself becomes more and more complicated. So Reval is meant to solve both of those problems. One thing worth noting is that there's no reload time, because it's not recompiling the code. and also that it is able to work on both the client and the server. So you guys have probably seen JS Fiddle, pretty cool. Lets you change front-end code. This also lets you change back-end code. So you can modify your entire application from within this environment. It can run entirely in the browser, as I'll show you, but there are also editor plugins that have been contributed by the community that allows you to use this live coding environment inside of the comfort of your editor. So down here, I have a link to the GitHub repo for Reval. OK, cool. So let's do a demo. All right, so I've constructed a demo application where I'm going to use these various plugins. Dima, are you ready? Cool. All right, so first I'm going to clear out the database. This is a little tool that I'll talk about in a minute. So first I'm going to clear out all of the users. Cool. All right, I'm going to name myself Lucas. So what this is this is just a silly little game that can actually support multiple players at once. All it does is when you click on a ball, you get some points. You get more points the smaller the ball is and the faster it's moving. It shows you a ranking over here of all the players and who's winning. Dima just apparently got some points. But I'm still winning. And soon I will be winning by a lot, as I'll show you later. All right, cool. So as I mentioned, there are two modes of Reval. So here's the first one. So this just shrunk the application. And one cool thing to note is this actually still works. This is just a mini version of the application. It does some crazy CSS transform stuff. And this mode is very useful for exploring large applications. So this is a very simple application, so it's not as complicated. But I can hold down a button, and it shows me the template that's underneath my mouse. So there's only two templates over here. But let's go ahead and open this. So I click, and then it actually finds the code that was underneath my mouse. Let's suppose that I want to start changing some random stuff. So let's say I want it to be inverted. It's a link. Oh, right here. Thank you, Jack. Jack is the creator of Semantic UI, so he knows the syntax really well. All right, so that just inverted the segment. As you can see, it happened instantly. What's neat is it also works for JavaScript. So let's go ahead and open the bubbles over here. And let's go ahead and here's all the drawing code that's drawing on this canvas. Let's go ahead and change the color a little bit, or at least the opacity. So let's say that I think that these are too transparent. There we go. Now it's darker. And you can see the changes over here. I'm going to go ahead and clear these out. This is the other mode. This is JS Fiddle. This is especially fun because you can see all the code at once. So up in the top left, you can see the template HTML code. In the bottom left, you can see the template JavaScript. And in the top right, you can actually see the server code. And as I type, I can have it update. So let's just do a few small tweaks that are kind of fun. So let's suppose I want to increase the velocity. So this is the update loop that changes the position of the balls over time. So I'm going to click. There we go. Let's suppose that I just want to halt it for a second, then return. Notice that it doesn't even appear to be reloading the page at all. It just like magically updates. This is actually reevaluating the code on the server. This isn't a special trick. This works for Meteor apps in general, and Qualia uses it every single day. And it really, really helps our development process. So let's do something slightly less trivial. So let's suppose that I want to change the color as it bounces off each side of the wall here. So what I'm going to do is I'm going to go to the update logic. And here we can see it's checking whether or not the ball is going out of bounds. So what I'm going to do is I'm going to update the color. I'm a fan of live coding, so if I make a mistake, that's part of the presentation. OK, so this is going to randomly update the color. And then I have to include the color in the actual collection update. Now we can see that every time it hits the side, it's updating. Maybe one more little neat thing. Let's suppose that I wish to have the radius shrink over time. So let's just do ball.r times 0.99, let's say. And we can update the radius. And now we can see the balls are getting smaller over time. And now let's have them get a little bit bigger. They're quite small right now. Dima apparently has surpassed me, which annoys me. And I will prove him wrong in just a sec. Okay, so let's just clear out the balls really fast. That's a mysterious thing that I'm about to talk about. Okay, cool. So this is a really awesome way to develop. You can sort of see as you type everything that's changing, and it's especially good for people that are just learning your application. You know, if you go into a complicated application and try to figure out what code governs what, it's almost impossible. And that's why this particular mode is very, very helpful. You know, just the power of being able to mouse over any part of the application and see the code which generated that is immensely helpful. Okay, so let's move on to the next thing there. So the next tool I would like to demonstrate here is something called Web Shell. I've already used it a couple times, but what this is it allows you to access the Meteor shell from within your browser. And this is super fun and convenient while you're developing. You know, one of the principles of Brett Victor, who's just this awesome designer, is that you should immediately be able to see the results of your changes. You know, context switching makes it much harder to develop, and this allows you to stay all in the same place. So what this is there's a key binding, which is control quote, that brings up this little semi-transparent terminal, and you can access the full Meteor shell with completions and color and everything. So this is dev mode only, but one of the things that I've noticed is that in the Meteor community, very few people use the Meteor shell in production, meaning very few people attach a Meteor shell to a running production server. This is a super key thing at Qualia. I have no idea how to run a production Meteor application without doing that. And the before this package this called prod shell, you had to do this very strange song and dance ritual involving like fake dummy files to like get the Meteor shell running. But I've released a package called prod shell, which lets anyone just add this package, and then you can SSH into your Meteor server and open up a Meteor shell. I was also working on a package that makes it so you can access the cool little in-browser Meteor shell in production, but I am concerned about the level of security given the risk there, so I haven't released it quite yet, but maybe I will one day after a bunch of people audit it. Okay, so let's use that. All right, so I am not a fan of Dima beating me. So I'm going to, let's see here. I'm going to find his user ID. Users.find.fetch. Okay, Dima. Apparently Sid, mwahaha, also. I guess Sid guessed the URL there, but. Okay, so I'm going to put in his ID. And, oh, I don't want to remove him, actually. That'd be mean. I'm just going to update. So I'm going to set his score to a really low value. Oh, yeah. Although it looks like Sid might pass me, so I'm also going to up my score. And all I have to do is get rid of the negative sign. There we go. Solidly on the top right there. You know, you can do anything that you could do from a Meteor shell in here. So, you know, I can remove the balls, and then it will start regenerating them. Yep. Cool. So, you know, this is very helpful in addition to reval. It just gives you this really awesome development environment. Okay. So now I'm going to do something quite ambitious for a live demo. Another thing that's really crucial to how Qualia develops with Meteor is the ability to take CPU profiles in production. So Qadira is an amazing tool, but it is only optimized for performance analysis of a certain kind. It helps you find really slow updates. It helps you find really slow publications, but it's missing a lot of information. If you guys have ever taken a CPU profile inside of the browser, then this probably looks familiar. This is a sampling CPU profile. It turns out that it's also supported by V8, by Node, and you can take it on the server. Once again, you used to have to do a bit of a song and dance to get it working, and this is a more convenient way of doing that that makes it more accessible to the community as a whole. So the package is just called Qualia Profile. It's also open source, so all you have to do is Meteor add Qualia Profile. It has several functions. So one, you can profile the Meteor server both in development and production. Also, interestingly, it allows you to profile code reloads. So for those of you that have large applications, you've probably noticed some slowdown in your code reloading. And this allows you to profile the build process, which as far as I know was never possible before, and see what's slow. So for example, I have been profiling the build process recently, and I noticed that like 30 to 40% of the time is spent in garbage collection. And so what we did is we increased the memory limit on that node process, and that actually improved reload times significantly. OK, so what I'm going to do is I'm actually going to give you guys an example of using this tool to diagnose a performance problem. And let's hope it works. Cool. Hopefully you can read that. Maybe I can go in just a little bit more. OK. All right, so I'm going to slow down the balls so I can actually click them. All right, that's more my speed. Also, I'm using a trackpad. I've played this game kind of surprisingly much, given that I made it like 12 hours ago. But I guess that's what you do before you give a presentation. All right, so this is kind of not that many balls, and it's kind of lame. So let's suppose that I want to increase the number of balls. Well, here's my max balls variable over here. We click Save. And now it's going to maintain 15 balls on the screen. Sometimes there may be a few more. All right, so the performance seems fine right now. But as I start clicking through all the balls, then it's getting laggier and laggier. Things are just starting to jump around. And it's pretty unpleasant if you're playing the game. Notice just all the jumping, and now it's like super slow. All right, so how do we figure out what's going on? Well, you could stare at the code, but this would take a minute to figure out what's going on. Wouldn't it be nice if there was something that just told you the function of what was slow? Well, there is, so let's do that. So I'm going to open up the Meteor shell here, and this is similar to some stuff that we do in production. So I'm going to clear it out. So what I'm going to do is I'm going to import the profiler from the Qualia profile package. And I'm going to profile the server process for 10 seconds. And during that 10 seconds, I'm going to click hold the balls so I can reproduce the performance problems. So this is going to save a CPU profile file onto my hard drive, and I'll load it up in a sec. OK, got to be quick. Oh, yeah, there we are. Getting some slowness there. Nice. That's what we want. All right, so it's written the profile to disk. So now let's go ahead and open up that profile inside of Chrome. So this is nice. You have the exact same analysis tools that you do when you're profiling client-side code. All right, let's zoom in here. So for those of you that aren't super familiar with CPU profiles, this is called a flame chart. And the x-axis is time. And on the y-axis, you have the call stack that's being executed at a given time. So at this point in time, the top-level function is run with environment, which calls some sort of anonymous function, which calls game loop, which calls create random ball. So it's really not good that there's no idle time in here. The game loop is only supposed to execute every 20 milliseconds, which means there should be a gap between every execution of the game loop. But this is going on for significantly more than 20 milliseconds. So let's take a look. All right, so the game loop function is the main function that we've written. And we can see that almost the entirety of the time that game loop is running, it's spending on create random ball. It also spends a little bit of time on this update balls function, but it's definitely dominated by create random balls. There's also all this other random stuff that's running, and it takes a little bit of practice to see this, but what this is doing, this is parsing the response from MongoDB. One thing that we've noticed in profiling a lot of production code is that an incredible amount of the time is just spent parsing the result from Mongo. So at some point, Qualia will probably offer a bounty, like a monetary bounty, for speeding up the BSON profiler. I think it would pretty much universally speed up all Meteor applications by quite a lot. All right, so let's get back to this specific problem. So we can see that it spends a lot of time in the game loop creating the random ball. We can confirm this by looking at aggregate statistics showing how much time is spent in each function. This ranks them, and we can see that a lot of time is spent in the game loop, 2.3 seconds, and almost all of that is spent in create random ball, which is a sub-function of game loop. So let's take a look at our code. All right, so we have our game loop here, which is just a small loop. And when there are fewer balls than max balls, then it creates a random ball. Here's the create random ball function. What this does is it has a loop where it creates a random ball and then checks if there's sufficient amount of space surrounding that new random ball, because we want to create a ball that's in empty space rather than that's overlapping with other balls. Okay, so here's the space free function. So we noticed in the profile that there's a lot of database lookups, which is kind of curious. You wouldn't think that it would need to do that many lookups. But as you can see here, it's doing balls.find.fetch, and this fetches every single ball from the database. And that's being called every single time space free is being called. Space free, if there are a lot of balls in here, might be called many, many times. So this is extremely inefficient, and this is the source of our performance problems. Now, balls isn't changing during this loop, so we only really need to do the lookup once. So let's go ahead and cache it so we only do the lookup once. And then we're going to pass it into space free. Now we need to take this argument. Okay. Awesome. So now let's try clicking over here. We can see that there's no lag now. And that seems to fix the performance problem. So that's an example of how you might use this profiling tool in production or in development to diagnose problems. I didn't have to read all the code. That was great. Otherwise, that would have taken quite a long time. Okay. So all those tools are open source, and I encourage people to check them out and also check out this particular demo. What I'm about to show you is not open source, unfortunately, although pieces of it are gradually becoming open source. You know, as we've matured as a company, we've definitely tried to give back to the Meteor community more, but it's definitely a gradual process. All right. So we call this Eden. Eden is it's essentially interactive documentation that is a running Meteor server that's running all of the core quality code and allows you to interact with it and dynamically change it. So we've created a very large library of components that allows to extremely quickly build applications. And some of them are very specific. You know, this is something that a nice sending message modal. Some of them are more commonly used. You know, we have integrated charts. We have something called edit card, which is a convenient way of editing data together. We have onboarding stuff. We have essentially we have tons and tons of stuff. And for the longest time, there was no documentation. And part of the reason why we didn't have documentation is because written documentation doesn't really communicate what everything is supposed to do. You know, I'm a big believer in running live code. All of our interviews, we don't do any whiteboarding. It's all coding. All of this demo did lots of live coding, and I think that's just the way that people learn the best. So let's look at a particular component. So let's look at something called quick search. So quick search binds to a server-side search and allows you to search over that index very easily. It essentially allows you to bind front-end components with back-end components in a very seamless way. The amount of code, this is searching something on the server, and when you select this value, you know, it can also store something on the server. So let's open this up using the tool that I showed you earlier, Fiddle. So we can see all of the code that's used to produce this example. It's quite small. This is all the markup, just some very simple options. And we can actually interactively modify things in here. So right now, it has 10 search results. Let's say that I think that's ugly. So I only want it to have 3. And now it only has 3 search results. And there's tons and tons of options available for this. You can see a lot of the different options available here. We also have significantly more complicated components. So here's grid view. So this is a table component that has just about every single option that you could imagine. It supports pagination and automatic binding to backend search indices. It supports column sorting, column rearranging. You can specify custom templates for the rows. It is also able to bind to documents in Mongo so that when you change things in this grid view, it automatically updates in Mongo as well. And once again, the code required to specify all this is tiny. And this is the reason why we've been able to build so fast. And this is something that can only happen in Meteor. If you just use a front-end framework like React, then you can't make an integrated SDK that also updates the backend and integrates with your entire stack. So just a couple more examples. This lets you update names in here, and let's say that I want to update the phone number, and this all updates to the database. So if I were to open this in another screen or inspect in Mongo, that you can see that all the changes just persisted there. So I'm just about out of time. One last thing that I would like to say is it's really important to teach core Meteor concepts. So one thing that we've done is we've created a series of interactive tutorials for new engineers that teach core concepts about Tracker and other pieces of Meteor. So this is like a partially implemented template right here. And there's a particular function that you have to implement, and you have to understand a core concept in Tracker in order to properly implement it. As soon as you finish typing and it works, this number will increment and be green. And some of these are quite complicated. For example, this last one requires you to implement a reactive var. And we found that this is a very, very effective way of onboarding new engineers. So that's all I have to say about that. So I'm just about done. It seems like we likely will not have time for questions. I guess if you can find me after the presentation, I'm happy to talk about anything you'd like. We are hiring. We're hiring very aggressively, and we'd love for you guys to apply. We're always looking for Meteor developers. You can go to qualia.com/jobs to see our job listings, or if you're here in person, find Max, and he is happy to guide you through that process. So thanks.
All right. Thank you, Lucas. That was fun. So Max is in the back over there. He's waving his hand. Another thing to make sure you do is you can sign up with your email at the table, and we can let everyone know when things are open sourced and keep you involved in our community as well. And we're going to have about a 2 to 5 minute break while we set up the next talk. Please get more food. The fridge with the light on has drinks, and we'll be back shortly. Okay, everyone, it's time to find your seats again. So we're going to get started with the second talk. This is pretty exciting. We have Ben Newman, who's the lead developer of Meteor, and he's going to be talking about the 1.7 release. So take it away.
All right, can you hear me? Seems like it. Okay. Yeah, welcome. It's great to see so many familiar and new faces here tonight. It's been a minute since the last time we did this, and I think it's always really great and healthy to have in-person events like this. I work remotely for Meteor from Brooklyn, and so my days are like filled with hanging out with my dog and working on this JavaScript framework, and so social interaction is just really rejuvenating for me. But I'm in town just for this, and that's my name. That's where we are. I've managed to snag the username Benjamin without the I on most forms of social media, including slides.com, which is this amazing presentation framework that I used for these slides. Well, you can judge for yourself how amazing they are, but it worked. Anyway, like Lucas, I had trouble coming up with accurate, like, content-specific title for the talk. Meteor 1.7 is just a number, and not even a very exciting number all by itself. But what I really want to tell you about is like the most incredible new thing that I feel like we've done with Meteor since the last time I gave one of these talks in person about 3 years ago. We've managed to find a way to compile code just for the very latest browsers without dropping support for older browsers, which is a balancing act that no one else seems to have accomplished yet anywhere in the JavaScript community. So that's what I'm going to be telling you about tonight, and some talk titles that we were spitballing at the office were different bundles for different folks. One size need not fit all, and my personal favorite, running with safety scissors. Meteor is all about that safety. So yeah, 3 years ago, intense waves of deja vu right now. I stood in front of a similar room and gave a similar talk, even on some similar topics. I felt under pressure then to justify a pretty big decision that we were making, which was to start using Babel and the ECMAScript Meteor package, which many of you have probably used quite a bit since then, to compile Meteor code before sending it to the client so that you could begin using new JavaScript syntax that had been proposed or specified but was not yet universally available in all browsers. And that was a big step, because before then you would just write your code and it would run in the browser as is, and you would have to deal with any inconsistencies in browser support yourself. And so adding another layer of indirection where we started changing that code before it ran in the browser seemed like a big deal. But in the intervening 3 years, the practice of compiling code before running it in the browser has become literally ubiquitous, and so I think that choice has been richly validated since then. But in service of justifying that decision, in that talk, one of the promises that I made was that if Meteor starts supporting a new JavaScript language feature, like say class syntax or generator functions, and you see a blog post about that, you start writing code using that syntax, then our promise is that you would not have to rewrite that code when native support finally catches up in all the browsers. You just start to benefit from the native support running the same code without compiling it. And I wasn't sure when that day was actually going to come, but I had faith that it would eventually come, and knew that if we stuck to this, then we wouldn't be sort of like luring people into trying something out that ultimately needed to be rewritten. So where are we now? well, 3 years later, it's quite a long time in JavaScript. It seems time to pose the question, has native support actually caught up yet? And I'm happy to say that while the answer to this question is definitely yes, so many of the things that used to have to be compiled before running in the browser can now just run directly in most recent browsers, this related question, can we stop transpiling yet, is paradoxically a definite no, right? So how is it that native support has caught up? And the whole promise was that eventually you were going to stop having to transpile your code because native support had arrived. But we can't stop transpiling, and in fact can't ever stop transpiling. Well, that's the world we live in, because this whole process of JavaScript standards and browser vendors is not approaching an asymptote. I mean, perhaps one day JavaScript will be complete and the TC39 standards committee will, disband its meetings. And at that point, major browsers will all catch up to that point, and you'll be able to stop using Babel or other tools like TypeScript to compile your code. But that's not happening. And my hunch is that forever there are always going to be shiny new JavaScript features in the future that you want to try out today. And so the kind of progress that we're making is that features you're using today, yes, those features will eventually become natively supported, but there will be a continuous stream of new features that you'll want to keep transpiling. So it's an ongoing process that has no end, and that's great news for our job security. So another way of unraveling that paradox is to observe, as William Gibson did, supposedly William Gibson in 1993, supposedly, that the future is already here. It's just not very evenly distributed. And this is true of a lot of things like income inequality, as well as JavaScript, browser support. But the natural follow-on question is just how unevenly distributed is this future that we find ourselves living in? If you'd told me in, say, 2006 or 2007, in the heyday of Web 2.0, when I was an intern at Meebo, the instant messaging startup, that a future was coming and made me guess what kind of future that was going to be, I think I could have believed you if you told me that this possibility number one was what was going to happen. So, every browser just kind of goes its own way, picks and chooses the JavaScript features that they want to support at their own pace, with their own meandering history of, partial support along the way. That's, I think, a totally plausible alternate history that thankfully has not happened. Another possibility, even closer to the truth, honestly, is that a single browser vendor might have emerged victorious over all the others. I probably would have thought that it would be Firefox in 2006, 2007, but today the browser that seems closest to that reality is Chrome. And if you do control the entire browser market share, you kind of set the de facto standard for web compatibility, and then web developers just have to do whatever you make them do. So that's a dire possibility that I think we have avoided, although Chrome's market share is increasingly impressive. A third possibility, also plausible, is that browser vendors might, over time, mostly come to agree, thanks to the JavaScript standards process, on what JavaScript should be and what web standards should look like, but many users might still be stuck on older versions of browsers, either because they can't or won't or don't know that they should update to the latest versions of browsers. And then possibility number 4 happens to be, I'll spoil it, I think, the truth, and I'm going to unpack this in the next couple of slides, but it's something that I don't think I could have anticipated back then as a web developer, that a new class of evergreen browsers would emerge, leaving the vanishing minority of nevergreen browsers, no one uses that term, but I think it makes sense here, increasingly far behind. So what do I mean by that? Have people heard of evergreen browsers? Is this a thing that, yeah, it's the best news. After coming to understand what this meant as a 2006 web developer, I would have been thrilled to hear that this is actually what happened. So what makes a browser evergreen? What does this word even mean? Well, it's a browser that keeps itself updated automatically. When I worked at Mozilla in 2008 through 2010, Firefox was definitely not an evergreen browser in this sense. You had to go into the settings and explicitly choose to update to the next version. If you have a browser that just actively keeps itself updated all the time, then there's no reason it can't support nearly the entire ECMAScript language specification. So these browsers that are in this new class of aggressively self-updating browsers basically don't have any gaps in their ECMAScript support, at least as far as what's been specified as of ECMAScript 2017 is concerned. And in another sense, something that all of these browser vendors share is that they're involved in the process, right? Like the reason that they're actively shipping these updates is so that they can figure out if this stuff works for people and give feedback into the standards process. I am a delegate to TC39 standards committee meetings, and most of the people in the room are representing browser vendors, and they all have very clear-cut insights from the literal experience of having shipped the features that everyone else was just talking about and getting real-world feedback from their users. And these are web browsers we're talking about, so that's billions and billions of users. So who are the evergreen browsers? Well, Chrome is a great example. Chrome sort of pioneered this practice. There's also Firefox now in that category. Microsoft Edge, right, which is distinct from Internet Explorer, is an evergreen browser, and that's great. I really applaud Microsoft for taking this plunge. They're distinctly uninterested in updating Internet Explorer itself, but it's understandable. They want people to use the new browser. And then this is Safari's logo, but it's sort of purple, right? Like that's the logo color scheme for a Safari technical preview. So what I'm trying to say here is that more recent versions of Safari have joined this game, and that's great. So what about these nevergreen browsers that just won't change? Well, of course, there's Internet Explorer, IE 10 especially, and earlier, and older versions of Safari. Now, a major caveat to give here is that while Safari has not always been an evergreen browser technically in the sense that it keeps itself updated, the Safari version is tied to your Mac operating system version, especially on iOS, and Apple is great about getting people to update to the latest version of iOS. So compared to Android especially, most iPhone users are using the latest version of iOS, which means they're using the latest version of Safari. So that's almost as good as Safari keeping itself updated. So I don't mean to shame Safari as much as I'm shaming Internet Explorer on this slide. So the truth of the matter is that these classes of browsers are within the class more similar to each other than well, they're very similar to each other within the class in terms of their support for JavaScript features. So that chasm is widening, and if you're still building just one client bundle for all browsers that you want to support, which probably includes older versions of IE and Safari, then you are, not to sugarcoat it, holding the majority of your users hostage to the needs of those ancient versions of Internet Explorer and Safari. Cool. And yet, that is exactly what most frameworks and applications do today, even if they use this tool called Babel preset env, which purports to give you a bundle that's tailored to a certain set of browsers that you want to target. That's helpful for not having to guess which Babel plugins are appropriate for those browsers, but you still end up with one bundle that you're going to send to all of your clients. This is an embedded iframe with some explanation of what that's all about in case, yeah. Anyway. And I understand. This is a choice that makes sense to me. The alternative to shipping one bundle which is shipping more than one bundle, is pretty daunting. Not only do you have to build multiple JavaScript and CSS bundles for different browsers with different dependency graphs and compilation rules and Webpack configurations, but your server also has to be able to detect the capabilities of each visiting client at runtime so that it can deliver the appropriate assets to those clients. And then testing, right? Like, we're all responsible web developers here. Testing a matrix of different browsers and application versions gets cumbersome. So it's no surprise that, you know, if you consider yourself responsible, you would rather ship a single, well-tested bundle and forget about taking advantage of modern browsers and their native capabilities until the legacy browsers have disappeared completely and you can just ignore them. Okay, so here's a word. Ontology is sort of your like personal understanding of like what the relevant objects and ideas in the world around you are and how they relate to each other. And it's sort of subjective. There's actually no like official ontology out there. Encyclopedias be damned. So when you make a choice about how to think about what the categories are in a design space like that of web development, your idea of like what you know, counts as a useful category informs all of the designs that follow from your sort of understanding of the world. So if you have the idea that the relevant categories here are, you know, each different major browser, and so, you know, probably you're going to be building a bundle for each browser, then that's 4 or 5 or 6 browsers, depending on how far down the long tail you want to go. Or double that if you want to make a distinction between older and newer versions of those individual browsers. And I think you'll see from the rest of this talk that that becomes pretty untenable pretty quickly. You could also maybe build different bundles for different ECMAScript feature sets. Maybe you decide that like a couple browsers support like a cluster of JavaScript features, and you know, you want to target that with one bundle, and then like target other browsers with a different bundle, and older browsers with their own bundle. That's another ontology, another belief about the world that you could have that could lead to a certain design here. What a lot of people do, honestly, is that they have one Babel configuration, and they compile all their code the same way, but they ship different polyfills to each browser. So, you know, things like array methods or the symbol type. Certain browsers need a polyfill to sort of pretend to support those things, and if you know that a certain browser doesn't need it, you don't have to ship that code to that browser. And you know, that shaves a little bit of size off of your bundle, but honestly the most popular way of delivering polyfills is this library called core.js, and if you use the entire thing, it's like 125 kilobytes, and if you try to use like just some of it, you end up through all of the interrelated dependencies using most of it in spite of yourself, so like, you know, 80 kilobytes, and that's just not a night and day difference, right, relative to the amount of work that goes into that. So I guess you could also go to the far extreme of generating everything on the fly and, you know, trying to cache your previous results if you really believe that the nirvana state here is to give every browser exactly what it wants. Anyway, what I would suggest instead, in order to clarify your ontology, is to ask yourself 2 important questions. First, how many different bundles are you willing to test? And second, what native features really matter the most to you? So on that first question, how many bundles are you willing to test? Obviously, the fewer the better. Like, testing sucks. I want to stress here, like, 1 is always a valid answer. If you don't have the bandwidth to test all of the bundles you're generating, you should be shipping 1 bundle so you don't have to test more than that. And of course, 1 bundle can serve many browsers because you can do dynamic feature detection. You can write different code paths that get executed in different environments. So you can be really flexible, but then you end up with each version of that code in the same bundle. So, you know, there's just some cost in terms of how much code you're delivering over the wire. And of course, like, even if you have a couple bundles that are just very similar, but they are not the same, you still have to test them separately because, I mean, the nature of programming is that little differences end up mattering. So to the question of what native features really matter to you, some questions that you might ask yourself: what have you actually been using through compilation or otherwise? What features would you use if there were fewer drawbacks to using them? Like maybe you've considered using generator functions to be prohibitively expensive because the compilation is really complicated and it sort of turns into a lot of code. But if they were natively supported, you would start using them, and that could be cool. How gross is the transpiled code? I'm the author of the regenerator transform that takes generator functions and yield expressions and turns them into an ECMAScript 5 switch statement inside of a while loop, and it's just like undebuggable. Like people tell me all the time that they don't use regenerator because of that, and I understand. When I wrote it, I was really hoping that it would become obsolete, but here we are. And also, is the native version really faster? Okay. We're going to have to speed up a little bit here. Anyway, you can decide what native features matter to you, but in Meteor 1.7, our answers to these questions are pretty straightforward. We're going to have 2 bundles. That's worse than 1 in terms of testability, but not so bad in terms of testability. One bundle is tailored just for modern browsers, and another bundle works for all supported browsers, both modern and legacy. And that's a really important property because the legacy bundle is a reasonable fallback in any case. And what does modern mean? Well, it simply means any browser that natively supports async functions and await expressions counts as modern. And the incredible thing, even though async await was just standardized in ECMAScript 2017, how many browsers out there do you think natively support async await? Well, this iframe stole my focus. Do you see that number? It's 84.53. Yeah, that's almost 85% of the world has access to a browser with native async await support. That's mind-boggling. 85% is like much larger than I would have guessed when I started this project, but it's not nearly enough to justify ignoring the remaining 15%. It's not 100%. The holdouts will die hard. There's a great article here you should read called The Slow Death of Internet Explorer and the Future of Progressive Enhancement by Alista Part. The good news, though, is that modern browsers are not some small emerging niche, but the vast majority of your users are actually using these modern browsers, largely thanks to the evergreen trend. And of course, if a browser supports async await natively, it supports all kinds of other things natively. So a lot of things follow from this. Maybe async await was too strict of a requirement. How could we change that 85% if we pick something like I don't know, ES6 classes? Well, yeah, sure. More browsers support ES6 classes natively, all of 87%, right? So that's not really better. So the lesson is you can't aim low enough to make Internet Explorer 10 happy. So you might as well aim high. Meteor 1.7 lets you customize the modern legacy system to your taste. And if you're going through these slides afterwards, just please note there are some vertical slide columns as well as horizontal. If you're writing a Meteor package, this is the way that, I hope that's big enough to see, that you would have added client and server code separately before. Well, now you can add code specifically to the modern bundle or the legacy bundle or the server like before. And in Meteor applications, this is actually a brand new feature in Meteor 1.7 independently of the modern legacy thing. In your package JSON, you can specify entry point modules, so you no longer have to rely on file loading rules and the imports directory. If that doesn't mean anything to you, don't worry about it. But one benefit of this is that you can do something very similar to what you did in a package and specify entry points for modern and legacy bundles. Okay, so once you've specified those entry points, you've divided your code into modern and legacy, you need to enforce your assumptions. And so there's this set minimum browser versions function that you should call, where you get to say what it means for a browser to be modern in your application. Breeze through this a little bit, but effectively the minimum modern version for each browser is the maximum of all the versions passed to set minimum browser versions for that browser. Right? So all the packages in your Meteor application sort of collaboratively define exactly where this line is drawn. There's a Meteor is modern Boolean that you can use if you really need to, although I don't recommend it. it kind of doesn't give you the benefits of this whole system. So this allows us to use totally different Babel configurations for the modern and legacy bundles. The plugins that we use for Babel are just like vastly simpler in the modern bundle because there's fewer of them. Yeah, this was a fun little example where I was talking about like some of the like error reporting that you miss out on if you're always transpiling let and const into var declarations. And I really just wanted to show this amazingly prescient picture of John Lennon and Yoko Ono. But we'll breeze through that. Just as you can have totally different Babel configurations, you can have totally different runtime polyfills. The ECMAScript runtime client footprint for Meteor applications is so much smaller. This is it for the modern bundle, and I would have to click through to a very large file to show you what it looks like in the legacy bundle. And this is music to my ears. The modern bundle never needs to import regenerator runtime, which is no small library. Okay, so what's the bundle size impact? This is pretty dramatic. So there's a bug right now in our bundle visualizer. We just haven't updated it for multiple bundles. So this pie chart is actually showing both the legacy bundle and the modern bundle in one, but that actually works because it gives you a visceral sense of like how much smaller the modern bundle is. So 25% of the whole is this legacy, the modern bundle, and the rest, the 75% here is the legacy bundle. And so much of that is due to, I don't know if you can see it, but core.js, right? And we're just using a lot less of that. I don't even know where it is on the modern side. So if you're not using the bundle visualizer, you should. This is the command that you can use. Okay, asset delivery. I would claim, like, you can build different bundles, and that's great, and now you've got a bunch of bundles, but how are you actually going to give the right bundles to the right browsers? Well, you need to detect at runtime what the capabilities of each visiting client are, and that's really hard. Right. So, yep. Bear in mind, it's not just the JavaScript bundle, but the initial HTML response that might be different between legacy and modern, dynamic imports, CSS, any other static assets. So our answer to this is that we use user agent sniffing. It's the only way to get it right in response to the initial request without doing any additional feature detection and HTTP round trips. It's really not as bad as it sounds, but that's mostly thanks to the simplicity of the rest of the system. Our task is a whole lot simpler than actually accurately identifying every individual client. Because every browser can handle the legacy bundle, we can always fall back to that if we're not entirely confident that a browser is modern. So at worst, like a fake spoofed user agent might receive the modern bundle by mistake, and that's just not the end of the world. Meteor handles every aspect of this. You don't have to think about asset delivery at all. So that's a virtue of Meteor managing its own web server, just a capability that's out of reach of most other web development tools. And everyone in the Meteor community will begin using this same system so that if there are problems, we'll be able to suss them out together. So asset delivery is actually the easy part in this whole equation, although it is the most challenging thing that I would expect other frameworks to contend with if they try to follow suit. So what if something goes horribly wrong? Well, that won't happen, but you're alone. You're not alone. I misspoke. You got several options. You could make the modern requirements stricter to fix the bug, or you could change how you compile legacy code. If you end up adding like additional code here to make that work, that's kind of okay because it's just the legacy bundle. You could also do the same thing to fix the modern bundle, but if you're trying to keep that modern bundle small, you probably don't want to add a whole bunch of additional code. You might just consider redrawing the line so that those browsers that can't handle a certain feature are considered legacy instead of modern. Okay, so that doesn't mean you should stop caring about legacy bundle size, but a lot of the benefits apply equally to both. So if you can, say, stop using an entire NPM package on the client, well, that immediately benefits both modern and legacy users. So a lot of those decisions are the same as they've always been. And I should mention, this legacy bundle that we've been talking about is the same thing that we've been shipping to every client in Meteor 1.4, 1.5, 1.6, right? So it's good enough today. It's just that the modern bundle is a lot better. We've deployed this minimal Meteor app website, which is an example of another Meteor 1.7 feature. If you run meteor create -- minimal, you'll get a very small Meteor app in terms of client footprint. And this is also a good way to debug like like on your phone, like are you seeing the legacy bundle? That's